is A-level chemistry paper, multiple choice question, May-June 2016. Let's start the question. Question number 1. Which equation shows the reaction that occurs during the standard enthalpy change of atomization of bromine? For this question, you must know the definition of atomization. In atomization, what is atomization? When 1 mole of gaseous atom is formed from its element. So you can see that in option A, there are 2 moles of bromine, so this is wrong. In option B, again, there are 2 moles of bromine, this is also wrong. In atomization, 1 mole of gaseous atom is formed. So in option C and D, you can see 1 mole of bromine, gaseous atom is formed from its element under the standard condition. Okay, bromine is element, but at room temperature, under the standard condition, what is the physical state of bromine? Liquid, not gas. So answer would be C. Question number 2. What is the correct number of bonds of each type in the Al2Cl6 molecule? So let's draw the Lewis structure or simple structure of Al2Cl6. This is the AlCl3 electron deficient compound, and this is another AlCl3 molecule. In both molecules, you can see that aluminum is electron deficient. In the outermost shell of aluminum, there are only 6 electrons. So for the sake of stability, this aluminum will share a pair of electrons with this aluminum and will make a dative bond. Similarly, this chlorine atom has 3 lone pair. So this chlorine will share one of its lone pair with this aluminum. So in this structure, there are 2 dative bonds and 1, 2, 3, 4, 5, 6 covalent bonds. So answer is B. Question number 3. Question number 3. Tetraethyl lead. In tetraethyl lead, has been used as a petrol additives. What is the percentage by mass of carbon in tetraethyl lead? So first of all, you have to find the formula mass. In the tetraethyl lead, Pb C2H5 4. What is the atomic mass of lead? 207. How many carbon atoms? 4 2s are 8. There are 8 carbon atoms, and each carbon atom has a mass of 12. So the 12 times 8, 96. Mass of carbon is 96. How many hydrogen atoms? 5 4s are 20, and each hydrogen atom has 1 atomic mass. So overall, the formula mass would be 207 plus 96 plus 20, 323. 323 is the atomic formula mass of tetraethyl lead. We have to find out the percentage of carbon. So what is the mass of carbon in 323? In 323, the mass of carbon is 96 divided by total mass into 100. So 96 into 100 divided by 323, answer is 29%. C is the answer. Basically, this is a long question, but the main question starts from here. In another nuclear reaction, uranium-238 is reacted with deuterium atom, H12. This is the isotope of hydrogen. What are isotopes? The elements having same atomic number. For example, you know that carbon has 3 isotopes, C612, C613, and C614. So same proton number but different masses. So in the isotopes, neutrons are different. but they have same number of proton. So in another nuclear reaction, uranium-238 is reacted with deuterium atom and isotope new element J is formed. Look at this nuclear reaction. In the nuclear reaction, the number of protons on the left hand side must be equal to the number of protons on the right hand side. So can you count how many protons? Uranium has 92 and hydrogen has 1. So total number of neutrons are 93. So J must have the proton number 93, because this neutron has zero proton. So J must be 93 proton. And what is the atomic mass on the left hand side? 238 plus 2, 240. So the total mass on the left hand side is 240. So the total mass on the right hand side should also 240. Each neutron has one atomic mass. So there are two neutrons. So it's mean the mass of J would be 238 and the proton number of the J is 93. 93. So look at the periodic table. Which element has the 93 proton number and which element? So you will see that Neptunium. So answer A. Question number 5. Dicarbon monoxide is found in the dust clouds in space. The structure of this molecule is this. Okay, look at the structure. Carbon has 4 electrons in its outermost shell. This carbon also has 4 electrons in its outermost shell. And oxygen belongs to 6 group. So oxygen has 6 electrons in its outermost shell. So the question is, how many lone pairs? Lone pairs are those electrons which are not involved in bond formation and are present in the valence shell, outermost shell. How many lone pairs of electrons are present in the molecule of C2O? So this is one pair, this is second pair, and this is third pair. So 3 lone pairs are present in the molecule. Question number 6. This question is related to mole. So let's start the question number 6. A white powder is known to be a mixture of magnesium oxide and aluminum oxide. 100 cm cube of 2 mole per dm cube NaOH is just sufficient to cause the aluminum oxide of the mixture to dissolve. Okay, it's mean NaOH can react with aluminum oxide, and this equation is also given. In this equation, Al2O3 reacts with sodium hydroxide. So first of all, find out the moles of NaOH. Moles of NaOH. How you will find the moles? 100 cm cube multiplied by 2 divided by 1000. So you will get the moles of NaOH 0.2. Okay. What are the moles of aluminum oxide? Moles of Al2O3. It is very easy. By comparing the molar ratio. In this equation, 2 moles of NaOH is used and 1 mole of Al2O3 is used. 2:1. If there are 2 moles of NaOH, so 1 mole of Al2O3 will use. If there are 0.2 mole of NaOH, so 0.1 mole of Al2O3 will use. So moles of Al2O3 is 0.1. Okay, look, another statement. 800 cm cube of 2 mole per dm cube HCl is just sufficient to cause all the oxide of the mixture to dissolve. First of all, find out the moles of HCl. Same method. 800 into 2 divided by 1000, you will get the moles of HCl. You will get the answer 1.6 moles. The reaction occurring are this. Al2O3 reacts with 6 moles of H ions. H ions mean HCl. So what is the molar ratio between the aluminum oxide and HCl? 1:6. But you have molar ratio is 1:6. If you have 1 mole of aluminum oxide, 6 moles of HCl will use. So how many moles of aluminum oxide is present? 0.1. For 0.1 mole of aluminum oxide, how many moles of HCl will use? 0.6 moles of HCl will use. So it's mean total moles of HCl is 1.6. Out of 1.6, 0.6 moles of HCl is consumed with Al2O3. How many moles of HCl is left? Moles of HCl left 1 mole. So look at the second equation. What is the molar ratio between the magnesium oxide and HCl? 2:1. If there are 2 moles of HCl, 1 mole of magnesium oxide is used. 2:1. And if there is 1 mole of HCl, it means 0.5 mole of magnesium oxide will use. So moles of magnesium oxide is 0.5 and mole of aluminum oxide is 0.1. So answer is D. 0.1 mole of aluminum oxide and 0.5 mole of magnesium oxide. Question number 7. At room temperature and pressure, water is a liquid and H2S is a gas. What is the reason for this difference? So, which type of forces plays an important role between the different physical state, liquid, solid, and gas? Intermolecular forces plays an important role. So it's mean if water is liquid and H2S is a gas, it's mean that strong intermolecular forces are present in water and weak intermolecular forces are present in H2S. So which type of intermolecular forces are present in water? In water, hydrogen bonding is present. And in hydrogen sulfide, we have dipole-dipole force and as well as London force. So what is the reason for this difference? Why water is liquid and H2S is a gas? I told you that hydrogen bonding is present in water molecule but not H2S molecule. So answer is C. Gaseous phosphorus pentachloride can be decomposed into gaseous phosphorus trichloride and chlorine by heating. Okay, this is the equation. PCl5, when you provide the heat, it decomposes into PCl3 and chlorine gas. What is the enthalpy change for this decomposition? So we have formula for the enthalpy change. Energy taken in minus energy given out. So when you decompose the PCl5, you will break 5 covalent bond which is present between the phosphorus and chlorine. And to break the 1 covalent bond between phosphorus and chlorine, you provide 330 kilojoules energy. And for the breakage of 5 covalent bonds, you will provide 5 times more energy than 330. So this is energy taken in, which you will provide to break the bonds. Energy taken in minus energy given out. When the bonds are formed, energy is released in the form of heat. So in this case, 3 covalent bonds are formed between the phosphorus and 3 chlorine atoms. So 3 into 330 plus, and 1 covalent bond is formed between the 2 chlorine atoms, 242. So if you do the calculation, 330 times 5, so it would be 1650 and minus 330 times 3 plus 242, you will get 1232. By using the calculator, you will get the answer plus 418. So basically this is endothermic process because all decomposition reaction is endothermic. Your answer is D. Okay, next question. An aqueous solution was prepared by containing a mixture of 1 mole of silver nitrate and 1 mole of iron sulfate in 1 dmq water. The equilibrium was established. Okay, this is your equation. Ag plus 1 plus iron 2 equilibrium silver solid and iron 3. Initial moles. AgNO3. In AgNO3, silver has plus 1 charge. So initial mole of AgNO3 is 1. And initial mole of iron in iron sulfate, FeSO4, iron is 2 plus. So mole of and 1 mole of iron sulfate. So it's mean the initial mole of iron 2 is also 1, and this is 0 and 0. Before starting the reaction, silver would be 0 and iron 3 would be 0. At equilibrium, how many moles of silver iron? 0.44. 0.44. Okay, what is the molar ratio between the silver ion and iron 2 ion? 1:1. In the equation, 1 mole of silver ion and 1 mole of iron 2 ion. So if at equilibrium 0.44 mole of silver 1 is present, iron 2 has also 0.44 moles at equilibrium. So how many moles of silver solid and iron 3 will form? Subtract the initial mole and equilibrium mole. You will get the moles of silver solid and iron 3. 1 minus 0.44, you will get the moles of silver. And there is again 1:1, 1:1, so moles would be equal 0.56, 0.56. Now, what is the numerical value of Kc? Kc is equal to concentration of product divided by concentration of reactant. So in this case, we have only one product because we will not write the silver because silver is in solid form. In Kc expression, we write only those compounds which are in the aqueous form or which are in the gaseous form. And silver plus 1 into iron 2. Now putting the values. What is the, okay, what do you think about the volume? Volume is 1 dm cube, so you can ignore the volume. By dividing 1, you will get the same answer, so we are ignoring the volume. So moles of iron 3 is 0.56 and moles of silver 1 is at equilibrium is 0.44 into 0.44. By doing the calculation, you will get the answer of 2.89. This is your answer. Next question. The equation for the reaction between the carbon monoxide and hydrogen is shown. What are the units of Kp? Okay, write the Kp expression for this. Kp is equal to partial pressure of methane, partial pressure of water vapors, partial pressure of carbon monoxide, and partial pressure of hydrogen P3 because 3 moles of hydrogen is used. So the unit of the pressure is kilopascal. So this is for the methane, this is for water, this kilopascal is for carbon monoxide, and there would be 3 kilopascal 3 times for the hydrogen because 3 moles of hydrogen is used. So you will get Kpa minus 2. This is the answer. Enzymes are the biological catalyst. Many enzymes show specificity. An example of an enzyme which shows the specificity is glucokinase. Glucokinase is involved in the metabolism of glucose. If you studied the biology in grade 10 or grade 11, you must know that there is a lock and key model in enzyme. For each lock, there is a specific key. Similarly, for each substrate, there is a specific enzyme which enhance the speed of the reaction in the living organism. So enzymes are very specific, just like lock and key model. So glucokinase only operates on a narrow range of a substrate molecule. Answer C. Why is the ionic radius of chloride ion larger than the ionic radius of sodium ion? Okay, uh, sodium and chlorine. If you look at sodium and chlorine, both element has three shell. Sodium has three shell as well as chlorine has three shell. But after losing the electron, sodium has now only two shell. And after gaining the electron, new shell will not add, but this chloride ion has three shell. So due to the one more shell in the chloride ion, the size of chloride ion is bigger than the sodium ion. So what is the answer? A chloride ion has one more occupied electron shell than a sodium ion. Yes, this is the answer. Question number 13. Element D and E are both in period 3. Okay. Element D has the smallest atomic radius in the period 3. Its mean this element D is the chlorine. Chlorine has the smallest atomic radius in the period 3, not argon. Most of the students argue that in the period 3, argon is extremely at right hand side, so argon have smaller atomic size. No, because argon, the size of the argon is bigger due to its van der Waals atomic radius. So chlorine has the smallest atomic size. There are only two elements in the period 3 which have the lower melting point than E. Okay, E is another element. E is the another element, and its melting point is at the third position from the bottom. So look, this is at y-axis there is a melting point, and x-axis there is atomic number. From sodium to magnesium, melting point is increasing because there is a strong metallic bond, and the aluminum has stronger metallic bond than sodium and magnesium, so its melting point is higher. And after the aluminum there is a silicon, and in the silicon it has the highest melting point in the third period due to its joint covalent structure. And then phosphorus, then sulfur, then chlorine, and then argon. So this is the silicon, and this is phosphorus, this is sulfur, and this is chlorine, and this is argon. So this is the phosphorus, which is at the third position. So E is the phosphorus and D is the chlorine. Your answer is D.